Okay, here we have AB Calculus AP exam, calculator section, problem number 2, the teapot cooling problem. So here's the question. As a pot of tea cools, the temperature of the tea is modeled by the differentiable function h, where 0 is less than equal to t is less than equal to 10, where time t is measured in minutes and temperature h of t is measured in degrees Celsius. Values of h of t and selected values of time t are shown in the following table. And here's our pretty table. Put that aside for later. Part A. Use the data in the table to approximate the rate at which the temperature of the tea is changing at time t equals 3.5. Well, if you look back at this table, we don't have anything about 3.5. Or do we? 3.5 is exactly halfway between 2 and 5. You add 1.5 to 3.5, you get 5. You subtract 1.5 from 3.5, you get 2. So it's exactly halfway between. So we know that h prime of 3.5 is equal to about h of t1 minus h of t2 over t1 minus t2. And we know that t1 is 5 and t2 is 2. So h of 5 minus h of 2 over 5 minus 2. Let's go back to our table if I can find it. Oh, here we go. We know that h of 5 is 52, h of 2 is 60. So 52 minus 60 over 5 minus 2 is 3. We get negative 8/3. The temperature is decreasing by 8/3 degrees Celsius per minute. Using correct units, explain the meaning of 1/10 integral from 0 to 10 h of t dt in the context of this problem. Use a trapezoidal sum with the 4 subintervals indicated by the table to estimate 1/10 integral 0 to 10 h of t dt. So that thingy represents average temperature of the tea over 10 minutes in Celsius. The integral from 0 to 10 represents a span of time. It's 10 minutes. If it was a graph, it would be from 0 to 10. And the 1/10 divides that into 1 minute units. And here we have our trapezoidal rule. The change in x over 2 times f of x0 plus 2 times f of x1 plus 2 times f of x2 on and on plus 2 times f of x n minus 1 plus f of xn, n being the number of terms. So we have that thingy, and it equals about 1/10 t1, t2, t3, t4, because remember, with the trapezoidal rule, we're basically making little trapezoids. So we find out what t1, t2, t3, and t4 equal, and we add them all up, and we get 529.5. So we get to plug in 529.5 for this whole integral thing. So we get 1/10 529.5, so we get 52.95 degrees Celsius. Over the 10-minute interval, 52.95 degrees Celsius was the average temperature. Evaluate integral from 0 to 10 h of t dt. Using correct units, explain the meaning of this expression in the context of this problem. Okay then, so we know from the fundamental theorem of calculus that integral from a to b f prime of x dx equals f of b minus f of a. We have our a and b. A is 10, b is 0. So we have integral from 0 to 10 h of t dt equals h of 10 minus h of 0 equals 43 minus 66 equals negative 23. So the temperature dropped 23 degrees Celsius over the 10-minute interval. Whoops. Part D. At time t equals 0, biscuits with temperature 100 degrees Celsius were removed from an oven. The temperature of the biscuits at time t is modeled by differentiable function b. And we know that b prime of t equals negative 13.84 e to the negative 1.173 t, At time t equals 10, how much cooler are the biscuits than the tea? I don't know, let's find out. So we know that b of 0 equals 100. At time 0, they're 100 degrees. And we have that function thingy. So b10 minus b of 0, we're getting a span of time there. Oh, we can put an integral in front of that. So we know that if we plug this into our calculator here, we do fnn negative 13.84 e to the negative 0.173 t, comma x, comma 0, comma 10. Hit enter, we get 65.8172. And because we're trying to figure out the change in the temperature there, we're subtracting that number from the original temperature. So we get 34.183. And we know that after 10 minutes, the t is 43 degrees. So h of t minus b of 10 equals 43 minus 34.183 equals 8.817 degrees Celsius. So after 10 minutes, the biscuits are about 8.817 degrees Celsius cooler than the tea. The end!